All right, welcome everyone. Welcome to this first 2020 webinar of the NEXUS project. I am Hubert Santerre, consultant at GAC Group, member of the NEXUS coordination team, and I will be today moderator for this event and also timekeeper. So please note that this webinar is being recorded right now, and it will be published later on the NEXUS website. Today's webinar is on one, if not the internet-related hot topic of the moment, advanced wireless and 5G technology. So we all know these technologies and debates are currently under a lot of scrutiny all over the world for good, right reasons and very, let's say, complex reasons. So today we are focusing on the right reason with the right people, and we intend to keep it that way. There will be 3 presentations by 3 different speakers. These 3 presentations will be of about 14 minutes each. Q&A will take place at the end of these presentations. So please write down your questions in the chat, and after the last presentation, we will select and make speaker address the questions you address. We will try to stick to the 1-hour format. Maybe we might get a little bit overboard, but please, for all speakers and for all people asking questions, let's keep as much as possible to the 1-hour format. And for now, I'm actually handing the floor to Fabrice Clary, coordinator of NEXUS, also my boss at GAC Group, who will introduce quickly the NEXUS project.
Thank you, Hubert. Thank you. So good morning to our US participants and good afternoon to participants from Europe. So as it has been said by Hubert, my name is Fabrice Clary, and we are working together at Group GAC. And well, I'm coordinating this EU-US project. So I will be quick today because I think we have very good presentation. So I will just spend 1 or 2 minutes on that just to give you some key information on the project. So NEXUS is a project which is founded by the European Commission. It's a CSA, what we call a support action, and stands under the NGI umbrella of the Commission. So you may know other NGI projects. And this one is part of the 3 projects which are dealing with EU-US cooperation. So this is the main topic of the project, and NEXUS aims at creating synergies between EU and US ecosystems in NGI-related thematics. In terms of consortium, so we have 5 partners in Europe, so GAC, acting as coordinator, ATC, Australo, SPI, and IMEC. And then we have partners from the US Ignite, and the University of Minnesota. And the project is supported by 3 working groups. So I will not go into detail now because we don't have time, but we have working groups working on various topics, and we will have other events in the next months to explain you that. I just wanted also to give you some information concerning next events, because we have a webinar tomorrow, so it's still time to register. In topics is Women in Tech. Tomorrow it's at 4 p.m. CET, quite interesting topic. And then we have webinars in September, one on AI and other one on the Privacy Shield. So I think you saw latest development during the last days, so we will do a webinar on that. So for the student webinars, we don't have date yet, but they will be communicated soon. And then we'll participate in an event, digital around the world, in October. So more information will be available on the website. And I think that's it for me. So I wanted to give you just a short intro, and then I will leave the floor to our speaker. Thank you.
Thank you, Fabrice. Thank you, Fabrice. Yes, so thank you for this introduction. And well, now we hand the floor to Mr. Glenn Reichert, founder and CTO of US Ignite. Well, I won't introduce him further. Basically, internet pioneer, sums it all. And yeah, please go for it, Glenn.
Thank you very much. Let's see. What do you see me, or do you see slides at the moment?
You can
We
see
see
both
both.
you. Yeah.
I'm sorry, I couldn't understand because you both spoke at the same time.
We can see you and the slides, Glenn.
Okay, you can see both. All right, excellent. Well, hello, my name is Glenn Reichert, and I'm the founder and chief technology officer of US Ignite. US Ignite has the privilege of being part of the program office that the National Science Foundation and 30 international wireless companies have formed to do advanced wireless research in the United States. That's called POWER, the Platforms for Advanced Wireless Research. And together with Northeastern University, US Ignite is responsible for working with a combination of $50 million from the National Science Foundation and $50 million that's been raised from these other wireless companies to be able to do research that goes, as we would say, beyond 5G. I think in the European sense, you would consider it to be an extension of 5G, but we are thinking about what goes beyond the kinds of 5G the US is implementing right now. We have 5G that is sort of 3GPP release 15 available in at least parts of a couple dozen US cities at this stage, and that rollout is running rapidly. But that doesn't mean that we have some of the advantages of ultra reliable low latency communications that are strengthened in release 16. So that's going to be sort of my focus, is what are we doing in advanced wireless research right now? And since the title of the seminar includes beyond, I'd like to go beyond that and talk about some of the ideas that are floating around for being able to go beyond the state of that current research. So I'm going to see if I can flip my screen so I can see my own slides. And I can there. Okay. So first of all, for those of you not familiar with US Ignite, it's really a nonprofit that accelerates the smart community movement in the United States and also in Canada and Australia by creating value for an entire ecosystem, guiding communities into their connected future, creating a path for private sector growth, and advancing technology research that's at the heart of smart community development. And as you can imagine, advanced wireless is really at the heart of smart community development because of the number of things that will be connected wirelessly. So on the top left, you can see the logo for the Platforms for Advanced Wireless Research. Again, one half of that is sponsored by the National Science Foundation, half from private industry. We are selecting 4 research sites in the United States. The one on the left that you can see is Powder. It comes out of Salt Lake City, Utah. Actually, I'm speaking to you from Salt Lake City. The University of Utah, together with Rice University, runs that Powder research effort. And we're looking in Powder into software-defined networking and massive MIMO, together with open software-defined networking of all kinds. Massive MIMO includes up to 100 by 100 MIMO, which is a specialty from Rice University, and could allow us to reuse our radio frequencies multiple times, which would be very helpful. I'll talk more about that if I have time here. Cosmos is in West Harlem, New York. That's done to try things with millimeter wave, extremely small cells, nanocells, and looking at ways for doing wireless backhaul. The third platform is called AirPaw and is out of Raleigh, North Carolina. And that focuses on unmanned aerial vehicles and mobility. So what are the requirements and wireless characteristics that we're going to have for those kinds of things? On the right-hand side of this chart, you can see a simulator called Coliseum that was pioneered by DARPA and is the world's largest wireless network simulator. And that's being used to go and take a look at spectrum sharing capabilities. We're also selecting, as you can see at the very bottom of the slide, a rural broadband platform, which will be coming late this year. We have 2 candidates. We're trying to take a look and see which of those candidates will be our rural platform. The rural platform will focus on rural communications, such as satellite communications that might be available from some of the constellations, the ability to do mesh networking, and other advanced wireless in those areas. So I wanted to go and give you a number of themes that we're seeing. First of all, the last 25 meters are really going to be wireless. And I don't need to spend much time on this, but I'm talking to you from a wirelessly connected laptop in a bedroom. So that wireless laptop is, the wireless in this house is communicating with, I think it was 24 devices, including a couple of light switches and thermostats and other things. And we're going to continue to see that in the last 25 meters because it eliminates a lot of cost of wiring. It makes it more flexible. Things can be moved around. You don't have to change wiring patch panels to be able to connect devices in different places. And the new versions of Wi-Fi, including Wi-Fi 6, are much better at sharing the bandwidth that's available within the home. We're also going to see a number of new pairs of things communicating. So one of the things that we're taking a look at is how might vehicles communicate with infrastructure to be connected vehicles and to be coordinated by metropolitan traffic coordination schemes that would have some degree of control and communication with vehicles that would really be communicating through that traffic communication system. You can see here a concept which is being implemented in testing right now in Colorado, which is a smart pavement. And the pavement itself would have the communications capabilities, would have the wireless capabilities, and maybe also power electric vehicles that are passing over. Electric power is being a little bit difficult to implement at the moment, but we've certainly seen some good demonstrations of wireless connectivity from under the vehicle. That allows very high frequencies to be used, which would mean that we can do very high data rates, which means we can do things in real time with the vehicles. It also means that's going to be very difficult for anybody who wants to intercept, well, intercept is the wrong word, but who would want to interfere with this communication, because it would only be 10, 20 centimeters between the pavement and the underside of the vehicle. And so it would be a very short distance that the wireless would have to communicate. As you know, the satellites constellations, about 5 companies are sending up satellite constellations. This is one from Starlink. And they're looking at a 12,000 satellite network that would encircle the globe and provide wireless communications to all kinds of areas which now don't have advanced wireless. That's a very interesting concept. We're looking forward to the success of some of these satellite constellations. Another one, of course, is that Google's Alphabet, well, Alphabet's Google really, has launched Project Loon in Kenya. This is a picture of that balloon in Kenya, and they're using that to provide connectivity to the Maasai people during this period of the COVID-19 pandemic. I think we're going to see a lot more of these aerial distributions. We're also going to see drones that are acting as carriers of large amounts of information. We're also seeing a lot of work to serve the underserved, especially in the United States, using meshes. This shows 3 main nodes serving a mesh of homes underneath. So in one project in Cleveland, Ohio, we have 60 gigahertz radios atop tall business buildings beaming down to a home in the center of a block, which has a really powerful Wi-Fi signal that is reaching other homes that surround it. And that kind of mesh networking allows us to go and have 1 downlink per block and still have very fast gigabit speed Wi-Fi in all of the homes in that block. And the primary application today is for neighborhoods which are not well penetrated, not generally because it's unavailable, but because financial reasons have kept Wi-Fi out of the financial range of the people who live there. We're also going to see, I think, a lot having to do with smart devices and smart homes. I've already told you how many devices I had online last I checked, and that might not be all of them, and some of them may have been asleep, but I think that a lot of things, including robots and other smart devices, smart appliances, are going to be communicating within the home, smart light switches. All of those things will really have a big impact on the amount of wireless traffic. Well, let's take a look at some of the considerations for going forward. There's frequency, there's time and time slots, and there's the ability to be able to coordinate that information spatially. So let's take a look first at frequency. So this nice little chart shows the United States frequency allocations, which you can see is a little bit of a over time, overly complex set of frequencies, which have been assigned for different purposes at different times in different ways. The Federal Communications Commission in the United States knows it's not optimal. We know that one of the things we need for advanced wireless is rationalization of frequency allocations. This is the frequency allocation for the 2.4 gigabit Wi-Fi band. And you can see that North America does not have as much frequency range available as Japan and Indonesia. Most of the world has yet additional frequencies. And when we go to the 5 gigahertz band for Wi-Fi, this is the map that goes and shows you, this is out of Wikipedia, what frequencies are allowed to be used in what ways in what countries of the world. Now, I know you can't read this, but across the top are different countries and groups of countries. And down the left are various frequencies that are allowed to be used and not used. And the International Telecommunications Union, which is responsible for harmonization of frequency use, will really, for advanced wireless, also need to be rationalizing international frequency usages. And whereas every sovereign country can make their own rules and have their own red spots and green spots on this map, for being able to have devices which can work well across countries, and of course wireless signals are going to cross country boundaries anyway, we need to have more harmonization there. We're seeing also moves to millimeter waves, which are much higher frequencies. They go shorter distances, but because they're more compressed, they can carry more information. And so we're seeing that 5G in the microwave band in 29 to 34 gigahertz rather, is really becoming much more deployed and has been deployed now in a few dozen US cities. Small cells are responsible when you have those higher frequencies because they can't penetrate as far. So remember that as the frequency doubles, we need approximately 4 times as many cells to cover an area, which means that small cells have to be much more frequently located. Let's go to time. This is how time gets divided in 5G. And you can see there are both slots and slub slots that get allocated. This is a very efficient mechanism for doing it. It's a big step forward. We're looking at research into how these kinds of time slots will be able to be further improved. Also, beamforming and MIMO for multiple antennas is going to be a way of reusing frequencies, which is going to be very important going forward. So again, right now we do this in a rudimentary way. We're looking for ways in which we can get up to 100 beams on the same frequency at the same time, and have a situation like this where a cell tower, for example, would have lots of antennas that could reuse the same frequency in many different directions, and also in many different paths. If there are reflections, as are present in downtown, the reflective path can have a different time to deliver the signal as a direct path, and being able to understand where the reflections are allow you to, again, to use the same frequency, even in the same sector, over again. Open access seems to be very important because it allows for competition in these new wireless capabilities. This is a list of companies that's available for people who are using an open access fiber carrier in Utah called Utopia. And we're going to expect to see some similar things for open access in wireless. So for example, here's an example of an open source stack that's being used by an organization called the Open Radio Alliance, ORAN. And that Open Alliance, which got originally announced back in 2018, but has now become really important, US Ignite is a member, and we're going to see, I think, a lot more folks because we want to make these devices work effectively in environments where we have competition. I think I was going to go on and talk a little bit about modern portfolio theory here and how that affects wireless, but in the interest of time, I'm going to conclude my presentation right there and turn it back to the moderator.
Many thanks, Mr. Reichert. That was perfectly on time and quite surprising to me. So many thanks for this presentation. Please keep on mind, and we might have time for you to continue elaborating on these aspects later on in.
Well, I think even better is refer people to the papers that we've written, and I've written a paper on this which contains many more details than I had time to cover today. So in some sense, consider my presentation an invitation to read the paper.
Invitation taken. Many thanks. So many thanks, Glenn, again. And now I'm handing the floor to Mr. Jacques Magin, Senior Project Manager at Australo and also Board of Director of 5G Infrastructure Association, previously Fireware also. So please, Mr. Magin, it's up to you right now.
Thank you very much, and thank you, Glenn, for this very interesting presentation. And for sure, I will have a look at the papers. Actually, I have a similar way of presenting today. I am going to give a presentation about a white paper that was released quite recently from NEXUS, which is called A Path for EU-US Cooperation in 5G, 6G. So as you could guess from the title, the objective, the main objective of this paper was to consider a kind of a framework for future direction in order to have Europe and the US cooperate maybe a little bit more than what we have been doing so far in 5G and in 6G. So as was mentioned, I'm a senior project manager at Australo. I'm involved in the NEXUS project. I am the lead editor of the 2 papers on 5G and beyond, including this one. Maybe we can go to the next slide, please. I have been participating in the 5G public-private partnership from the beginning. I'm a member of the board of the 5G Association, and I am also a board member of the Network 2020 European Technology Platform, where I chair the SME working group. So my talk today is going to be structured in the way you can see on the screen now. So I will first give a short introduction, then I will try to present where we stand in terms of EU-US cooperation in 5G. Then I will try to recommend or to suggest that there are a few opportunities ahead for this EU-US cooperation. Then I will go into a little bit more details and making the case for such a cooperation and even providing some ideas for the next steps. So here on this slide, you can see where you can download the full white paper. And there is also a shorter policy brief that is a kind of a companion to the white paper, and you can see the link here as well. But let me start with setting the scene somewhat. So I don't know how many people in this audience I need to convince, but there are many people around the world who believe that 5G is of strategic importance for the global economy. And unfortunately, the COVID-19 crisis is only demonstrating this further. So if we look at what Europe is doing, where the European Commission has just initiated a revised action plan for 5G and 6G. And actually, on the one hand, what we want to do in Europe is to set the right framework to enable operators and all other stakeholders to invest, of course, in 5G network and service solution. and obviously in line with competition law principles, and I'll come back to that in my speech. But also, on the other hand, we want in Europe to incentivize European companies and research organizations to start developing and building technology capacities in 6G. Actually, a lot of people are talking about 5G and beyond, and now more and more we hear the words 6G. So that's what I am going to use today. So in fact, the EU in its industrial plan believes that connectivity is the most fundamental building block of the digital transformation. And even further, European technological sovereignty is a term that we are hearing more and more often. And ensuring the integrity and resilience of the data infrastructure, networks, and communications is really something that is critical. But this is not only critical in Europe, it's also critical in the US. The US recognized that 5G is critical to its technological leadership, and it placed it actually at the heart of the EU-China trade war, taking measures to prevent US deployment of network equipment from the Chinese manufacturer Huawei, and even at one time considering buying one of the two leading European 5G equipment manufacturers, Nokia or Ericsson. I think this was a little bit forgotten, but I mean, this shows how important that is for sovereignty and for technology. So why this interest in 5G? Because there is a major concern in security and privacy of the 5G network. Because the main reason why there was this problem in the US with Huawei, because the US believed that there were risks that information circulating on the network via such equipment was being disclosed and sent to the Chinese government. In Europe, actually, we also see that there is a critical need for security and for privacy. We've seen the recent implementation of GDPR, the General Data Protection Regulation, which has actually been imposed somewhat by the EU as a global standard. And this has demonstrated, if needed, that user privacy and data protection in general is considered as a privacy in Europe. So basically, if we finish setting the scene, what I would like to say is that the EU and the US both consider 5G to be critical for technological sovereignty, and 5G networks shall be secure and trusted and ensure privacy by design. So based on those European-US commonalities, I would like to explore opportunities for the EU and US to cooperate further in 5G and 6G. Can we go to the next slide, please? Thank you. So this is the key summary of what I just said. Now, I would like to go a little bit further in the current status, actually, and give you a little bit of figures. There are many figures going around, but basically, I will give you a few of them. The global market for 5G technology is projected to reach 667 billion by 2026. And by 2035, 5G may contribute up to more than $13 trillion of potential global sales activity across multiple industry sectors enabled by 5G. And this is really important, and I'm going to come back to that. But in the telecommunications sector, the current largest telecommunications equipment manufacturer is Chinese. It is Huawei, followed by two European companies, Nokia and Ericsson, and then another Chinese company, which is called ZTE. There are diverging reports on forecasting who will eventually be leading the 5G infrastructure market, but obviously some see Huawei and China well positioned to see the most economic gains from the 5G rollout. And actually, the recent measures by the US to ban Huawei has only slowed down a little bit the pace of growth, but it has certainly not stopped that. Okay. In Europe also, there is some concern, and actually 5G has been a kind of a wake-up call for EU regulation in the future somewhat. So what is really important is that investment in 5G and 6G infrastructure shall and will continue, okay? Because that is what is important to start with. So the successful rollout of highly secured and state-of-the-art 5G network will be a major enabler for future digital services, and it will be at the heart of the industrial data wave. And actually, Europe must invest if it wants to be a front runner in 6G networks. This is the same in the US, because besides the Secure 5G and Beyond Act of 2020 signed recently by President Trump, he also signed another act, which is called the Broadband Deployment Accuracy and Technological Availability Act, that will help the US get a map of where investment is more needed in terms of infrastructure. So really, investment in infrastructure is key. However, and we can go to the next slide, there are opportunities for EU and US to work together, probably beyond the 5G infrastructure. Because if we look at the market, the 5G infrastructure market is estimated between, I mean, there are different figures, but between $45 and $60 billion by 2026, 2027. So if we look at the whole projected 5G market, this is basically only less than 10% of the whole market. So why is that? It means that more than 90% of the market enabled by the implementation and deployment of 5G still lies beyond the network infrastructure. And actually, when we look at the telecommunications market itself, it's been stable since 2018, and it is likely that it's going to remain stable. However, where is this 90% coming from? Well, it's coming from the rising demand from various vertical applications that has been recognized as the major driver for the 5G infrastructure market growth. Now, I'm not going to give you too many figures because, you know, I mean, it's a little bit difficult to do that just with a webinar. But basically, once again, I mean, although the ICT sector might be the first one to be impacted by the deployment of 5G, there are many, many opportunities in other areas. So some of them are, for example, transport and logistics, manufacturing, media and content, smart cities, agriculture, energy, healthcare, and so on and so forth. The first ones where we might see the application of 5G concretely are probably automated cars. I mean, Glenn presented that already a little bit. Also augmented and virtual reality in the media and content sector, and solution for smart cities. And there are already a number of 5G trials going on in Europe and probably elsewhere in those areas. So this is where probably we are going to see transformation for the life of businesses and citizens, but they will be followed by many others. So there are many opportunities that will open in the years to come in vertical markets thanks to 5G. And this was actually anticipated by the 5G PPP that has since its inception implemented a strategic plan to gradually involve the vertical stakeholders in the project, in addition to the telecommunications and ICT ecosystem. Now, where are the opportunities in that? Well, there are opportunities in those vertical sectors. And in addition, 5G is likely to bring disruption in business models, you know, not only in the telecommunications area, but also in the vertical sectors. So that means that there are opportunities, and maybe some of those opportunities, of course, are going to be grabbed by the incumbent players, but there is room, at least I am convinced there is, for SMEs that are well introduced in vertical sectors and that are maybe a little bit more flexible to be the first to grab those new opportunities. In any case, what is really important is that innovation and entrepreneurship is going to have a key role to play in grabbing some of those 5G related opportunities. So if we go to the next slide, I will, which is a summary of what I just said. Okay, I think there are opportunities ahead, and I want with those opportunities to show the case for an EU-US cooperation in 5G and beyond. So basically, if I try to summarize the situation, the emergence of 5G network infrastructures is opening opportunities for developing innovative and disruptive solutions for vertical sectors enabled by 5G, for example, in sectors such as automotive, media, or smart cities. And I think this is where a cooperation between Europe and the US could prove most fruitful. What is important to understand is that we need to address and to access global markets. This is really essential for success, especially when it comes to startups, spin-offs, and SMEs. All right. So this is really important to have access to a global market. And when it comes to 5G, the current largest market is in the US, but there are forecasts that show that Europe is the fastest growing market, especially due to the large presence of large software providers and the high investment plan in 5G by Korea. So basically, the EU and the US represent the two largest 5G markets in the world. And as addressing and accessing global markets is essential for success, once again, especially for startups and spin-off, as well as for SMEs who might be trying to reach or trigger new markets, this is where an EU-US cooperation could make sense. Okay. There are different strengths in Europe and the US when we look at the industrial landscape. I will not go into many details, but basically, although Europe has been trying to make a lot of effort to promote more their startups to become global leaders, we still see that in the US. And the US has proven that they are really, really good at doing that. But trying to access the US market from Europe or the European market from the US is always a challenge, especially when it comes to small companies. So basically what I want to say with that is Europe and the US will best cooperate in 5G and beyond by building on each other's strength and market. So that's really, really important. At the same time, when we talk about 5G, there are a lot of people who believe that the future is bright. However, the 5G revolution is going to take some time, probably up to 10 years, especially when it comes to bringing 5G and 6G enabled solution to vertical sectors. That means that if we are looking at a Europe-US cooperation in 5G and beyond, we need to talk about the long term. So this is really what we should look at. Can we go to the next slide, please? Yeah, so this is basically the key issues that I just raised. So now that we've said that, what next? What next? So actually, in the telecommunications sector, the cooperation between the EU and the US has been mainly focusing on research infrastructures. Actually, US Ignite, if I'm not mistaken, is involved in one of the EU-US projects, also in the 5G PPP, which is called Empower, and it is really focusing on the type of topics that Glenn presented to you a little bit earlier. What is missing from our perspective is a shorter time to market and a focus on a more industrial ecosystem. So this is where we see that there are many relevant issues for a Europe-US cooperation that may not have been addressed yet. So for example, large industry and research organizations could work together to promote global standards, and also, that is really key, provide the infrastructures and the platforms that are required to develop and test 5G and 6G enabled products and applications. And the SMEs then could be encouraged and supported to use those infrastructures and platforms to develop innovative and disruptive 5G enabled solution in key vertical industrial sector. So this is why industrial partnerships involving all the pieces of the value chain of a given industrial sector should be really promoted. So how do we do that? Well, there is already a roadmap for EU-USA scientific and technological cooperation, which has been signed in August 2017, and that could, for example, be amended to provide this framework. Maybe we can go to the next slide, please. Thank you. So basically, what I want to conclude with is that it's really important to put together a framework for designing European-US joint initiatives and implementing projects that could focus on the most relevant 5G and 6G issues to be addressed together by Europe and the US. And this needs to be done as soon as Horizon Europe kicks off. And we need to focus there, in addition to what is already being done, we need to focus on a short-term time to market, and a more industrial partnership ecosystem should be targeted. Now, of course, the implementation of the 5G and beyond EU-US joint framework would then even involve all the relevant stakeholders. That means industry, public authorities, but also the SME support and financial ecosystem, because this is how the SMEs can play a big role in this game. So with that, I want to conclude my speech. I just want to say one word about the policy brief that is a little bit the companion to this white paper. The policy brief gives a little more details and focus more on how to put in place a pre-commercial 5G and beyond trial infrastructure with a 1 to 3 year time to market, which we believe is an essential component for developing innovative and disruptive 5G enabled applications. Thank you very much.
Many thanks, Mr. Magin. It was a little bit more than one word, but that was perfect and very interesting in any case. So before introducing the next and last speaker of this webinar, please, to participants, do not forget that you can actually ask questions to Mr. Reichert, Mr. Magin, and Mr. Ahiar through the chat. So should you have any question, please go for it in the chat, and we will manage at the end to have 3-5 minutes maybe to make speakers address this question. Now, Mr. Hui El Ahiar, professor at the University of Aveiro, senior member of IEEE, and I don't want to even mention even more of the very long resume you have under my eyes. So you are with us and you're just out of the World Summit on the Information Society Forum, if I'm right. So the floor is now yours.
Okay, thank you very much. Thank you for this invitation, and sorry I joined late. This is one of those days that you really wonder what you are doing. I think you are going to pass my slides, right? I've seen a message here that I was making the presenter, but you will be passing my slides.
Absolutely, they are now actually online. I mean,
okay,
on display.
Perfect. So thank you for this. Let me add something which was actually a problem for me. I've been asked to talk about the EU toolbox for 5G. As you will see in a couple of minutes, it's an effort that involves many countries. And I am a member of the Portuguese team that addresses that. Actually, to me, the challenge was suddenly I found out that not everything that I knew was public. So I had to figure out what can I say or not. So in the end, I took, I would say, a very didactic approach to this. After all, if a professor cannot be didactic, who can? So I'm going to try to give you an idea about what is this so famous EU toolbox for 5G. So next slide, please. So why do we have this? I think Jack already mentioned. I think we are all tired of hearing this. Society is becoming digital. Communications is increasingly, a part of society. We will not have this webinar if it was not for communications. In fact, in my case, by a huge amount of things that I'm actually using cellular networks to access this. 5G networks will give all of us a step forward regarding how much we can make society rely on communications. And there is just a small problem. They are more softwareized, more distributed. So for all of you that understand a little about cybersecurity, you understand what this means. We just increase the attack surface of a network. So how can we build a society that relies on a more unsafe approach in terms of system-wise? Next slide, please. That's actually why it appeared EU toolbox. We want to define measures to mitigate the risks. Note that per itself, 5G is, safer than 4G, but overall context of the network make the situation more dangerous to society. So next slide, please. So what are the objectives? The EU, as you probably understand, it's a very complex body. Okay, so we are not a union, we are not a federation, we are something that it's usually defined as the European Union. And please read the 200 pages of the treaty to understand what it is. And then spend 5 years in Brussels. So it's a really complex environment, and things are more or less reached by sort of consensus or agreement respecting the individual authority and sovereignty of the different countries. So the EU toolbox, what it wanted to do is to basically have two things: to provide a common set of features that everybody could try to follow, and to provide some guidance on how the countries should be aligned in implementing those features for cybersecurity. Yes, each member state will make their own choices. So we will have each member states that, depending on a huge amount of aspects, to define how it's going to realize their improvement on the cybersecurity of the network. But there will be an overall harmonizing approach. Now, this toolbox is sort of facts oriented, but it's still vague enough for being used for geopolitical reasons. And you've heard Jack just mentioned a lot about the potential geopolitical aspects. And if we talk about sovereignty of countries, there is no way that they will not be involved. So there is a place for that as well in the EU toolbox, although the major purpose of it is to provide a facts-based approach. So next slide, please. So the toolbox is divided in 3 major parts. Okay, so we have something which we call the technical measures, and if you are an engineer, you probably will feel very comfortable with this. You will understand what these are, because this really reflects aspects associated with objective measures, strategies, policies, anything that a software or a security engineer would recognize. Now, then we have strategic measures. Strategic measures are much more oriented towards policy and strategic objectives. So economists, people from social science, law enforcement, regulators would be much more involved in these kinds of measures. And finally, we have support actions, and support actions are accompanying measures. So can we go to the next slide, please? So time-wise, and this is the formal time plan with a couple of months ago. I'm just warning. There is a warning that not all of these dates have been fulfilled recently after COVID. But I don't think that the official timeline has been updated. So let's keep these names. This date. Also, something which I don't think has been already reflected. There is now a EU target from the new from the current Commission to develop another cybersecurity political policy by the end of the year. And I believe that is expecting the development of this EU toolbox in order to settle political guidelines for the whole European Union. So basically, how has this come? The idea was very simple. We started with a report to the European Parliament by the European Parliament, understanding the dangers of or the need to improve the cybersecurity of networks. This moved to the European Council. Then there was a recommendation to the member states. The member states agreed on a coordinated risk assessment for 5G networks, and there was a couple of bodies in Europe which were mandated to sort of coordinate these, in particular ENISA. Now, most recently, the member states are reporting on how they are going to implement the EU toolbox that was sort of approved in the beginning of this year, and by I would say the end of this month, a new report will be prepared reflecting what's going on. That draft report is already known, but from my point of view, is still very much vague. I don't really expect a fully detailed report to happen until the end of October. So next slide, please. Next slide. Yeah, my network is apparently so. Technical measures. I'm not going to enumerate all of them, okay? But just to give an idea about what we're talking about, we are talking about making sure that the implementation of 5G security measures will happen, provide techniques and approaches to improve physical security, or try to develop formal EU certification for 5G network components, networks, and so on. Improve techniques for software integrity, and measures more or less along these lines. Next slide, please. So the next slide, which should have appeared, we'll be talking about strategic measures. Strategic measures are different, and if you see words like assessing the risk profile of suppliers. Part of this is technical, part of this, as we've just heard, it's simple geopolitics being discussed, and then things like identify key assets, and these assets are more than, or potentially more than, the network itself. We may be talking about military aspects or the public protection aspects. Then aspects like making sure and building diversity and European Union self-capability of providing solutions on these areas. Finally, and the next slide, we have the associated measures. Now, I would say that in some aspects is, so I hope it's the associated measures slide that we have now. Next one. So these are, I would say, the kind of actions that we also call support actions. And these are things like best practice, improved coordination, the role of ENISA, improving cooperation, making sure that there is a link between the public funding and the overall objectives of security. So next slide. This is just an example. This is an example of part of the things that was done. Do you remember that I just mentioned about that there was some risk analysis performed? So each country actually had to go to its own assessment of its own network and its own country features, identify potential risks, look at how each one of the strategic and the technical measures could reflect in those risks, and then I had to assess the formal status of these risks. If they already had measures in the country that would make those risks, low risk values, or if there were some features in their countries that would lead to very high risk values. Saying this, and this has been already done by all countries, and next slide, please. What we have moved on is how can we minimize the risks that were deemed, significant. And one good thing about it is that where we are moving, it's about moving into formal technical approaches. And both GSMA and 3GPP have developed some models for assurance standard and certification. The discussion is still very much ongoing, but the fact that we are having some sort of formal technical standards in place already is being quite helpful in leading and harmonizing the discussion, because this is really a discussion being handled at a mixed technical and political level, or at least policy. Next slide, please. So to finalize, what kind of conclusions can we extract at this moment? Well, one thing is that there is no conclusions. This is an ongoing process. You saw my timeline. This process will be finished by the end of this year, but clearly in many countries, it is clear that some of the measures that will be applied are measures that will require a continuous monitoring and assessment of the safety and reliability of their network. And as such, in the end, this process will not finish. What this process will do will be continuing across multiple member states where they will be exchanging their experience. But for now, it's clear that there are two levels of responsibilities and two levels of conclusions that have been reached in terms of administrative, or at least borders of responsibility. Okay, it's the problem for the member states to define its specific measures to improve the security requirements for MNOs and to guarantee the risk profile of the suppliers. Also, it should have measures to ensure that each operator will have some sort of resilient approach in order to avoid lockdown situations. Actually, maybe I can say this, since this is something that I personally did. We have developed a strategy which takes a national view to this approach, which is, I think, a very interesting strategy, because the cornerstone of that strategy is that at a given point on critical areas, you should have two fully independent communication passes. So it doesn't really matter if it's an operator or two operators or three operators. What matters is how the national system behaves. Now, finally, we also conclude that the EC has a responsibility to guarantee that there is in Europe a sustainable 5G supply chain. It may be, by coordination, but for instance, we talked some moments ago about Huawei, but we have Cisco as well, which is incredible dominant on the market. We have some other companies which have very strong positions on the market, and that poses a security risk. So I think that as time goes by, we will see the European Union having a sort of attention or paying attention to guaranteeing this diversity of this 5G supply chain and making sure that our capacities in Europe in 5G and beyond 5G technologies is going to improve. This seems to be clear. Both Jacques and myself, for instance, are quite involved in the discussions for the new funding for research in Europe, and these are things that are being put over the table precisely. Also, something that it's responsibility of the European Commission and something that member states are discussing, quite strongly, is how can we set European-wide certification schemes? So what are the approaches, what are the technologies? And in that aspect, the standards that are being put in place may definitely be quite helpful. So thank you very much. I think this concludes my presentation, so I will be welcome to answer your questions.
Many thanks, Mr. Ahiar. Many thanks for this presentation and for sharing indeed this very important information, in a way, very touchy information with us participants. So actually, I do think that Mr. Glenn Reichert, Mr. Jacques Magin, and Mr. Riel Ahiar were so crystal clear in their presentations that we don't have any question in the chat. So given the fact that we are already 5 minutes overboard, I would actually ask all participants who do have questions to send these on the website of ThinkNexus, and you just go to remember the contact part of the ThinkNexus website and ask your question there, give your reactions, and also we will keep you informed with the papers that were mentioned, the white paper, the technical paper from Reichert, and then, well, not the paper from Mr. Riachiar, because it's not to be open in the wild right now, but yeah. So thank you very much for our speakers to have such a great presentation. Thank you to all participants for having attended to this first webinar of 2020 for ThinkNexus project, of course. Keep in mind that tomorrow we have another, let's say, touchy topic to address with empowering women in tech. So it is online. There are all the information on the ThinkNexus website, on the NDI website, and yada yada yada. Go for it, and yeah, we will keep most definitely in touch for the next webinar and for the next EU-US collaborative activities on 5G, advanced wireless networking, and beyond. Many thanks to everyone, and well, we keep in touch.
Okay, bye-bye. Thank you.
Thank you.
Thank you. Bye-bye.
Bye-bye.